Hello and welcome to your third and final part of the Algebra 2 SOL practice items for the 2016 standards. Let's continue. Remember again what our best practices are here. Remember to think concept, not algorithm. Why am I doing this? What am I doing exactly? What does this really mean? When in doubt, write it out. We give you plenty of scratch paper, use it. Let the calculator be your helper, not your guide. Remember, the calculator's only going to be as good as the person putting in the information. In the end, just do your best. You'll regret doing anything less than that. Okay, which of the following describes the end behavior of the function h of x equals x minus 6 on the top and x squared on the bottom? So the first concept here is that we're looking at end behavior. So you're going to graph this function. You're going to take a look at what it's doing on the ends of the graph. So far into positive infinity, far into negative infinity. So far to the right, far to the left. What is it doing as it goes, in this case, specifically to negative infinity? And here we have the graph of x minus 6 over x squared. So on this graph, if I'm looking at as x approaches negative infinity, then I'm talking about going far in this direction. And you can see that this shape is getting closer and closer and closer to a y value of 0. And that's what we call the end behavior. So if I traveled this way forever and ever, what would it get closer and closer to? In this case, 0. Okay, so this one says, which of the following is the inverse of g of x equals x cubed minus 8? So the main concept here is we're looking at inverse functions. So that means that x and y get swapped. So if I had ordered pairs, I would just switch the x's and the y's, and that gives me the inverse. If I have a graph, I can draw the reflection of that graph over the line y equals x. But we're going to find this algebraically, and to do that, we're going to swap the x and the y. So again, we're finding this algebraically. So the first thing I'm going to do is rewrite it with a y instead of a g of x. Then I'm going to swap the x and the y. Because remember, that's what we said, that's switching. And this is how you find this algebraically. Now we're going to solve for y. That means get y by itself. So I'm going to add 8 to each side. X plus 8 equals y cubed. I'm going to take the cube root of each side. So the cube root of x plus 8 equals the cube root of y cubed. Let's clean that up a little bit. So the cube root of y cubed is just going to be y. And y equals the cube root of x minus 8, or excuse me, x plus 8. And we say that g inverse of x, so with the negative 1 exponent, that's inverse, is equal to the cube root of x plus 8. So our correct answer is C. This one says, which of the following describes the end behavior of the function f of x equals 9 times the log of the quantity 2/5 x plus 5? Again, we're looking at end behavior, so it's how the function behaves at its end. And normally that's positive and negative infinity, but this is a logarithm. You cannot take the logarithm of a negative number. You cannot take the logarithm of a negative number. Therefore, 0 is actually the end of this function. Let's take a look at the graph. Here you go. As x is approaching 0, and it's coming from the right, that means our y value is going lower and lower and lower and lower until it gets to negative infinity. So A is my correct answer. This next one says directions. Type your answer in the box. And it says g of x equals 2x squared minus 5, and h of x equals x over 3 minus 7. And you're finding g of h of 12. G of h of 12. So this is what we call a problem on composite functions. Just a moment of just a quick point here. This is also a TEI. So you type in your answer in that little box. And if the character you're trying to type in doesn't go there, it's not going to let you type it. It's also only going to let you type enough characters to answer the question. So those are important things to recognize. So anyway, again, the concept here is composite functions. In this case, we're putting one function into the other. That's what g of h of 12 means. So let's write the workout for this. On this problem, you're going to start off by finding the inside here, h of 12. So that's take the x and replace it with a 12. And that's going to come out to 12 over 3 is 4, minus 7 is negative 3. And then we're going to find g of that answer. So we're going to take the g of x function, which is the 2x squared minus 5, and we're going to plug in that number we just got. So negative 3 squared is 9. 2 times 9 is 18. Minus 5 is 13. This one says, the table shows the height in feet of a baseball above the ground x seconds after the ball was hit. And it gives you the table. It labels one with x and the other thing with y, and then it says which equation best models the data. This is a regression question. Regression deals with taking data, graphing it on a coordinate plane, and figuring out a model of an equation they can use so that you can predict later data. Say that you wanted to predict the number of cars that go through an intersection to help figure out whether or not to put a light there. You might be able to do that with an equation after a whole lot of observation. It's not a perfect equation. It doesn't fit every single data point usually, but it does match the model of the data, so it can be used to predict future values. So regression, and we use our calculator almost exclusively for regression. Okay, so you see 3 screenshots here. The first, you get to by pressing Stat and then Edit. You put your X's in list 1 and your Y's in list 2. A couple of quick notes. Always proofread at this point and make sure you type the numbers in correctly. Also, make sure that your lists are the same length. Otherwise, the ordered pairs won't graph and you'll get an error. Then we viewed the scatter plot. You do this by turning on the stat plot. You can do that at the top of the y equals screen or by pressing second y equals. Then you want to use Zoom 9. Zoom 9 is your friend when you're dealing with problems like this. It's going to make this specific window visible, so it's going to fit your statistics values that you put into your stat lists over here. And then at this point, I looked at that graph and I said, oh, well, that right there, that's a curve. That's a parabola. That's quadratic. That means it can't be B and it can't be D. Those are linear. So which one is it then? Well, when I graphed both of them, the blue one was first and the red one was second, and look at how close that red one fits the data. That means that this is the correct model for this set of data and the correct answer for the question. Here we have another regression question. So the amount of lost revenue from tickets not sold is shown in the table, and the ticket price includes tax, which is not really an important thing I need to know here. But you'll notice that you have an extra line in the table right here. But it tells you which one's X and which one's Y. So this information is extraneous. Again, we're dealing with regression. Notice this time we have two kinds of equations as again, like the other one. We have linear, just like the other one, but now we have exponential. Interesting. Let's take a look at what it looks like on the graphing calculator. Well, I went ahead and graphed my scatter plot, put in the numbers like I did before, stat, edit, etc. Turned on the stat plot, and then I went ahead and I graphed the two exponential ones, because while linear might look okay, it's not good enough. The exponential one definitely matched. And once again, it was the second one. 997 times 1.03 to the x power. So this question says the volume of a container varies jointly with the square of its radius r and its height h. And then it gives a bunch of information about the container, and we've got to find a volume knowing the original information. This is a variation question. We learned about 3 kinds: direct, inverse, and joint. We also learned that with each type of variation there is a constant. Strangely, they use the variable k for constant, but that helps us remember. Just think how silly it sounds to say k for constant. The constant value is the same throughout the whole variation, and that's what we have to find in order to answer this question. The volume of the container varies jointly. That's important here. Let's go ahead and let's actually highlight that. Let's find the highlighter. Varies jointly. Varies jointly with the square of the radius and the height. So when I write this equation, the volume varies jointly, that's my equal sign. And now I have K, a constant of variation. And you always have a constant of variation in these problems. So the volume varies jointly with the square of the radius, so r squared, and the height, h. There's my formula. That's my equation. The next thing I need to do is find K. So it tells us that the height is 10, and when the radius is 6, remember to square it, we still don't know K. It tells us the volume is 377. So when I multiply this out, 6 squared is 36, times 10 is 360. So 360K equals 377, and that means I can divide to find K, divide by 360, and that's my K value. I don't like decimals. I don't like dealing with them. I don't like having to round them off and be wrong all the time after that. I'm going to leave this a fraction. I also know I can use my calculator to help me with fractions. I'm finding the volume. I have my constant. And now I have my radius squared times height. And when I multiply that out, it comes out to 67.0222. So our answer here is 67 cubic centimeters. Okay, this one says a normally distributed set of 968 values has a mean of 108 and a standard deviation of 11. How many values are above 125? Okay, so first of all, normal distribution. Normally distributed data makes a bell curve, and a larger percentage of the values in a set of normally distributed data are towards the middle, which is where the mean is. Also where the median is in a normally distributed set of data. We're also dealing with z-score here. When you find the z-score, you can use those probability tables that come with your big formula sheet that you get for this test. You can use those tables to figure out how many values fall in a particular range in that normal distribution. So the first thing I want to do here is I want to find the z-score. So z-score is found by subtracting the data point in question minus the mean and dividing by the standard deviation. In this case, that means 125 minus 108 over 11. Well, that's 17 over 11. And if you then make that a decimal, it's 1.545454, and so on. So at this point, we're going to take this number and we're going to go to our normal, our probability table. So here is a section of the probability table. And so you know that the z-scores are shown, and we're looking for a z-score of 1.5 and then 4, which is right here. And what this number represents, 0.9382, is 93.82% of the values in this normally distributed set of data fall below a z-score of 1.54. Let's pretend that's right here. So that means here's where all the numbers that are below 125 would fall. How can I figure out how much would be above 125? Well, if 93.82% is on one side, we just need to find the rest of the 100%. So take and subtract 100% minus 93.82, which is going to give you 6.18. So 6.18%. So that means I need to find 6.18% of 968 values in the data set. And the easiest way to do that is going to be to multiply. Oh, I ran out of space. Multiply 0.0618 times 968. So when you multiply that, you get 59.8, etc., which we round down to 59. Okay, we have another normal distribution question. This time it gives you the heights of, it says that heights of 200 kindergartners at this particular elementary school are normally distributed with a mean of 40 and a standard deviation of 1.8 inches. Approximately how many students have a height between 37.3 and 44.5? So this involves finding the space between two parts of our normal curve. So again, we're going to use normal distribution, we're going to use z-score, and we're going to use our probability table. Let's do a little bit of the math on this page first. Let's find the z-score of each of these values they asked me about. So 37.3 is the x value, minus the mean, which is 40, divided by the standard deviation, which is 1.8, and we get negative 1.5. The other one, 44.5, minus the mean of 40, divided by the standard deviation, and this time we get 2.5. Okay, so what do I use those for? All right, so here you have the two values from the z-score table for the negative 1.5 z-score and for the 2.5 z-score. Let's think about what these represent real quick. So let me draw this. So here's my normal distribution. Here's my mean. At a z-score of negative 1.5, we're probably talking about from here over. Okay, and that would be 0.0668 or 6.68% of the kids. Then we have this one that's from 2.5 down. And so that goes all the way to the end. And so that is 0.9938 or 99.38%. And so what we're going to do is we're going to find out, well, how many of the 200 kindergartners would be there. So we're going to find 6.68% of 200. So you do that. Oh, let's switch back my colors. You do that by multiplying 0.0668 times 200. And that one comes out to be 13.36. Okay, which will round down to 13. And then on the other one, we find 99.38 or 0.9938 times 200. And we get 198.76, which we are going to round up because we don't have 76 hundredths of a child to 199. The next step is going to be to subtract those. 199 minus 13, which comes out to 186. This is one of the acceptable answers. It turns out they would have accepted 186 or 185 or 184, which is interesting. It just means that they're giving you a little bit of credit for how much we have to simplify. Now, I know I didn't use the calculator too much for these, but that's because I find it very hard to remember the process for doing this on the calculator. If you already had that down, you can always do it that way, as long as you got the correct answer. Okay. This one says, a store owner employs a total of 3 cashiers and 7 clerks. The owner plans to select a committee of 1 cashier and 2 clerks. What's the number of different committees the owner could choose? Express your answer as a whole number. Okay, so this question involves the unit you did on something called combinations and permutations. A combination is a way of counting the number of outcomes in a situation where the order of those outcomes does not matter. A permutation is where the order of the outcomes does matter. For example, this is a committee. So this is a combination because the order of the people doesn't matter if they're sitting on a committee together. But if it had said president, vice president, and treasurer for a committee or something like that, that's different because being president is different from being vice president. Therefore, in that case, the order would matter. You have formulas to help you solve questions like this that are on your formula sheet for this test. You also have some calculator shortcuts for doing this as well. So here you see screenshots both of how to find the calculator shortcut and also a quick shot of your formula. We'll go ahead and we'll write out the math for it because I'll show you that it's actually really easy in case you can't remember how to use the calculator on this. But in this problem, since you have 3 cashiers and 7 clerks, you're picking 1 cashier out of 3. That is a combination of 3 things taken one at a time, meaning I'm only picking one thing out of the 3. Then you have on this one 7 cashiers, or 7 clerks, excuse me, and you're choosing 2. So that's a combination of 7 things taken 2 at a time. N is the first number, R is the second number, as you can see here in the formula. Let's do the math. 3 factorial over 1 factorial times 3 minus 1 factorial. What does that factorial mean? Factorial means multiply all the way down. So 3 times 2 times 1. You don't go any further than that because then you'd be multiplying by 0, and that doesn't make sense anyway. Then in the denominator, 1 factorial is 1, and 3 minus 1 factorial would be 2 factorial, which is 2 times 1. So the total for this comes out to be 3. There are only 3 ways to choose one cashier. You choose person A, person B, or person C. Well, that makes sense. For 7 things taken 2 at a time, it's 7 factorial over 2 factorial times 7 minus 2 factorial. So that's 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial is 2 times 1. 7 minus 2 is 5, so 5 times 4 times 3 times 2 times 1. Well, you'll notice that in these problems, you can cancel out the common factors. Boom. That was fast. Now I can cancel out common factors between 2 numbers that aren't the same, but they're divisible by the same number. So I can divide up the 2 and leave a 3, which means I multiply 7 times 3 right here and get an answer of 21 for this section. And then since I'm finding the possibility of both of them, I multiply those numbers, and 63 is my correct answer. Believe it or not, folks, this is the last question. A family reunion planning committee with 8 members plans to elect 3 officers, a president, treasurer, and historian. We just talked about this. I didn't say treasurer and historian. I said vice president, treasurer, but still. If each office is to be held by one person, and no person can hold more than one office, in how many ways can those offices be filled? Again, this is in this case, permutation question, because the order of the people does matter. There's a formula for this. It's on your formula sheet, and you have your calculator. So there you go. Your formula is very similar to the other one. It just doesn't have the r factorial in the denominator. That's because permutations have more results than combinations, because when the order matters, the same 3 people are different if a different person is president each time in that set of 3 people. So this is a permutation of 8 things taken 3 at a time, in this case people taken 3 at a time, and let's do it out. 8 factorial over 8 minus 3 factorial. So that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 minus 3 is 5 times 4 times 3 times 2 times 1, because 8 minus 3 is 5. 5. The 5, 4, 3, 2, 1 cancels. 8 times 7 times 6 is indeed 336. And that is our correct answer. All right, folks. Take the time to practice, and remember to just do your best. In the end, it'll be okay. Thanks for watching.